Before we perform optimization, let us add few more parameters and responses to the design study. So let's create simple line supports for the given part. So to do that, let's navigate to the tab Help and open the startup screen. And inside this, we will find an example to create the simple line supports, which is this one, pre-processing for AM manufacturing. And if we open this file, there is this snippet to calculate the line supports or to generate the line supports. So we can copy this and paste it to our document here. And here we see that we have to input only the mesh and it will create the line supports. So let's take one of the parts from the list and then plug it here. So here we can see that it has created simple line supports. So we can clean this curve input in order to have no null values in the list of curves that goes for constructing this line supports. And at the end, we got the total volume of the line support. So we can link this response to our parameter study and rename this as the total volume of line supports. So as we have observed, this component response can be used for linking it to the parameter study, and it can be used either as an optimization objective like this, either to minimize. So in this case, let's minimize the volume of the line support, or it can also be used as an optimization constraint. For example, we know that the total volume should not exceed like 1000 millimeters cube or something like that. So then in that case, it can be used as an optimization constraint, and that value can be defined here. So let us also link this response to our parameter study, this one. And now we have another response to our parameter study. We can go and check out the parameter study, and here we can see that the new response is added automatically. So now we have two responses, that is the cost per part and the total volume of line supports for one part. So let us also add another parameter to our design study, which is machine selection. So how do we do that? We have an Excel file with different machines and the data for each of the machine. So if we open the machine selection Excel file in the directory, it looks something like this. So here we have three different machines and the dimensions of the machine, the build rate, the machine preparation time, and the staff cost and the overhang angle. So let us import this data into the software. So here there is already a small snippet that imports the data from the Excel file. So here we can use this component read Excel file and select the file that we want to import, which is this one, machine selection. And then this is the sheet of the Excel file that we want to import. And here we can define the cells that we want to import from the given sheet. So here we can see that we can switch between different machines, that is 0, 1 and 2, which represents three different machines. And at the output, we have these parameters. So we can now connect these parameters to our component LBM Costing. So let's connect them, the overhang angle and the dimensions of the machine, which goes here, X, Y and Z. And then we also have the material price, which goes as an input here, and we have the build rate, the machine preparation time, and also the staff cost. So now let us link this machine parameter also to our design study. So we can do that, as we know, linking it to the parameter study. So now we will have to perform parametric optimization between these new parameters and the responses along with the old ones. So here there is a warning that the parameters have changed, so we have to compute them again. So let's compute them again, like 5 experiments because we will have to perform parametric optimization anyways. So we can evaluate these designs. So now we just perform like 5 experiments in order to understand the sensitivity analysis. So how do we do that? Let's delete this component and use this one called sensitivity analysis. And for the parameters and responses, we can give these ones that we have. So here, if we go inside this sensitivity analysis, it gives us a nice report between the parameters and the responses. So these are called the coefficients of importance that gives a factor between the parameters and the responses. For example, if we are not interested in one of the parameters, we can simply check that out and it will be removed or ruled out from this list. Or if we have like the threshold of the sensitivity, we can move that, and then we will see what parameter is most important and how sensitive it is on the response. So here we can see that the rotation angle Y has the most sensitivity effect on the total volume of the line support. So here we can also switch between responses and responses, and this one gives the coefficient of correlation between the responses. And here in the report, it also shows the top 3 highest influential parameters from the list of parameters that we have in the parameter study. And it also shows the sensitive responses, these ones. In our case, we only have 2 responses. And it also gives the correlation coefficients between the responses on the report like this. And at the end, it shows the type of the algorithm that used to calculate these sensitivities. So for the responses versus responses, which are the correlation coefficients, it uses the linear dependency. But for the coefficients of importance between the parameters and responses, it can also go to higher dependency. So now let us perform the parametric optimization. So to do that, we can simply use this component optimization, which is this one. And here we can link the parameters, and an optional start design can be given here. So if we click on setup and run, we will see a window something like this. So now we haven't started running the optimization yet. Here are some of the settings to run the optimization. So this is the maximum runtime that is allowed in seconds to run the optimization, and these are the maximum number of iterations that are allowed to run the optimization. And here we also have some advanced settings such as convergence evaluation, that is between the 2 functional values, and how many restarts. So let's use the default values for now and start running the optimization. The optimization is finished now. So we can close this window, and here we have some of the outputs. So these are all the designs that have been calculated during the optimization, and here we have the best design and its respective index. So please note that the optimization runs based on the settings that we defined, such as the maximum runtime, the number of iterations, and also the advanced settings that we had a look. To extract the parameters of the best design, we can deconstruct it using this component deconstruct design. And here we can see that it gives out the parameter names, which we know, the rotation angles and the machine, and it also gives the responses names. And here we can extract the parameter values, and here we can see what were the response values. So these are the best combination of parameters that optimize our objectives. So this is the end of this session. In the next session, we will learn how to perform the nesting.